Welcome back to today's Explainer. You know, when you toss something in the trash, it basically vanishes from your life, but definitely not from the planet. Today, we're diving into exactly how waste management entities measure and report their greenhouse gas emissions step by step under the SASB standard.
So how exactly do these entities account for their invisible impact on the climate? Well, landfills are actually one of the most significant anthropogenic, meaning human-caused, contributors to global greenhouse gases. Think of them as giant, slow-cooking ovens just constantly generating methane. Because of this, regulators are watching the industry like a hawk. Tracking these metrics isn't just about good PR, it's absolutely crucial for regulatory compliance and managing some very real financial risks.
Okay, let's dive into this. We'll decode the standard today in 5 quick steps. The Greenhouse Gas Challenge, reporting Scope 1 emissions, calculating total landfill gas, flaring versus energy recovery, and finally, strategy and future targets.
Section 1. The Greenhouse Gas Challenge and Why Methane Matters.
In the waste management space, greenhouse gases pose massive regulatory and capital risks. If a company doesn't proactively control its methane output, they can face huge capital expenditure risks for unexpected facility upgrades. Looking at the SASB sustainability topics here, notice that very first row on greenhouse gas emissions. This standard provides a highly structured, quantitative way to report and manage these specific climate-related risks, tying those environmental outputs directly to a company's financial realities.
Moving right along to Section 2, reporting Scope 1 emissions, specifically metric IFWM 110A.1.
This metric lays out the rigorous requirements for calculating gross global Scope 1 emissions. And let's clarify what we mean by gross here. These are the greenhouse gases emitted directly into the atmosphere before you account for any offsets, carbon credits, or any other compensation mechanisms. You have to report the raw, unfiltered number calculated perfectly in line with the globally recognized greenhouse gas protocol.
But what exactly are we tracking? Well, you can't just track carbon dioxide and call it a day. The standard requires tracking 7 specific gases covered under the Kyoto Protocol. We're talking carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride.
So, how on earth do we combine 7 wildly different gases into a single, readable metric? It's kind of like a giant puzzle, but we follow a strict 3-step workflow. Step 1. Identify those 7 Kyoto GHGs in your operations. Step 2. Apply the 100-year global warming potential, or GWP, values to each gas. This basically weights a gas, like methane for example, much higher because it traps significantly more heat than CO2 over a century. Step 3. Consolidate all that math into one clean reporting unit, metric tons of CO2 equivalent.
Actually, scratch that. Getting that total isn't the whole story. Entities also have to divide these emissions to show what percentage falls under emissions limiting regulations, like strict cap and trade schemes, versus emissions reporting mandates, where you just disclose data without a hard limit. Doing this shows investors exactly where your regulatory vulnerabilities are hiding.
Next up, Section 3, calculating total landfill gas under metric IFLWM 110A.2.
Now, what's really interesting about this slide is how we shift from global emissions to the raw gas generated right at the landfill. This landfill gas is the direct byproduct of the anaerobic decomposition of buried waste. Basically, it's organic waste breaking down without oxygen, creating this massive, highly potent gas burden.
And to put that into perspective, we don't measure this generated gas in tons. The standard explicitly requires a very specific unit, MMBtu, or million British thermal units. It's an energy-based metric, which makes perfect sense when you realize this gas is essentially a raw fuel source if you manage to capture it.
Which brings us right to Section 4, flaring versus energy recovery, how we actually manage that gas.
Generating the gas is one thing, but managing it is the real challenge. Facilities generally handled captured gas in 2 main ways. First, there's flared gas. This is combusted using an open flame, which dramatically cuts its toxicity and global warming potency before it hits the atmosphere. Second, it's used for energy. Instead of just burning it off to neutralize it, the facility combusts it to generate on-site heat or power, or pipes it off-site as actual usable fuel.
To build out that full compliance picture, you literally have to slice up your total generated MMBtus. You have to report the exact percentage flared, the percentage utilized for energy, and whatever is left over as uncaptured. Regulators and compliance teams absolutely need this breakdown to see exactly how efficiently a company is controlling its most potent byproduct.
Finally, Section 5, Strategy and Future Targets. Let's look at the big picture.
So the crucial point is that all this data collection has to actually drive business strategy. If a company shifts toward waste-to-energy operations, they can significantly decrease future life cycle emissions from their landfills. That's a huge win, right? Well, the catch is that operating those very facilities will actually increase your immediate, short-term operational Scope 1 emissions. It's a real strategic dilemma that companies must evaluate and discuss transparently in the reporting.
And if an organization has set emission reduction targets, vague promises definitely won't cut it. You've got to provide rigorous details. The scope of the target, whether it's absolute or intensity-based, the exact base and target years for your timeline, and the actual practical mechanisms you're going to use to achieve it.
So here's a thought to leave you with today. As you look at these environmental trade-offs, is your organization prioritizing the short-term management of Scope 1 emissions or the long-term reduction of life cycle emissions? How you balance that scale doesn't just dictate your compliance under SASB, it really dictates your future in a carbon-conscious world. Thanks for tuning into this explainer, and keep questioning how the invisible impacts around us are being measured and managed.